Hello, engineering students. Uh, as we prepare for your exam, which I think now you know it will be on Monday, the 24th. 24th of May, from 8:30. I can say that we've not had a formal revision class, particularly face to face, and I just thought that I needed to give uh, some revision tips, even as you prepare for Monday, so that I think you'll be able to be aware of what is expected of you, and uh, uh, especially regarding the approach on some of the questions. For example, um, uh, we've done cut one and cut two, and the because of the multiple choice approach, the type of questions are not what you'd actually expect in a typical exam, in which you're just being given a structure and then you're told to really come up with a name, or maybe you're just given a name and then you're told among the choice here, which is this structure and that. That's really a very simplistic approach, which is normally given to high school and whatever. But wanted to give you, excuse me, some of the three things that need to uh, probably two, because uh, I needed to mention that uh, naming or IUPAC nomenclature is normally a standard thing that is normally asked, and I wanted to show you some of the standard approaches that are usually taken in our exam. And the other thing is that they are usually calculations. So wanted the second part of the video is going to be on some of the things that you should have revised on the calculations, because calculations, they are quite they cover a lot of topics in the course, and you've not had a formal revision session on that. So let me just go to the first session, and then I think in the second video we're just going to cover some aspect of the calculations, and then I'll just otherwise than that I'll just be able to tell you the overall view of the expectations. I don't normally give leakage, but I just want to say there's something so that you'll be able to see the standard which is going to be expected. I don't give and say that this is what will be expected, this is what you are going to really find, but that is not standard of university, but just to give guidance on the expected standard that is normally allowed, and that's what I'm just going to spend in this few sessions. So like the first one, uh, got to say that and this one you're going to see probably in the papers of last year and the previous before. We've been taking a new approach on how to test, especially if they're likely to be questions on nomenclature, which which I must say all the engineering papers on chemistry too normally cover on nomenclature. I'm not saying that you expect, but if there will be questions dealing with nomenclature, over the past 2 years, we've used a certain approach which I want you to, which I want to bring to you. And this is the fact that you are not going to be given a name and then you come up with a structure, or structure and then come up with a name, but the standard way which tests on your intellect is for you to be given a name which is not correct as far as something you call IUPAC nomenclature is concerned. But using that information on the name, you're supposed to reconstruct a structure containing the various functional groups as they are laid out in the name. And then now, from the structure which you have constructed, you now derive a proper IUPAC nomenclature. Can you see? This is a strategy which tests both your how you can be able to read a name and construct a structure, and then how to come up with a structure and then come up with an IUPAC name. Two concepts in one. This is the standard manner, standard approach in which we actually test. Yeah. So I want so I've just given some four examples here on some of the names here, and just to save on the time, I've just decided from this name, uh, this is the you'll be expected to reconstruct like a structure like the one which I've shown on my left, and then from there we'll try to see how we can be able to come up with a proper proper what proper IUPAC nomenclature. So, for example, you can be given a name such as like an option. The first question, there is a name like 3-hydroxy 4-oxo hexane. Can you see how they are put in dash 3-hydroxy 4-oxo hexane? I'm just trying to give an example of something like that, so that in this case you're going to know that you're dealing with something like what a hexane. So you're going to draw your zigzag, those bond line structure of 6 carbon atoms. Yeah, and then from there you're going to say, hey, on carbon number 3, I'm going to put a hydroxy, and you need to know that a hydroxy is when the the alcohol group is a substituent. The name changes to be a hydroxy. So it is telling you that you've got a hydroxy group, an alcohol group or an alcohol group on carbon number 3 of the hexane. And then this is telling you that on carbon number 4, you've got an oxo group. It means you've got a carbonyl group. I mentioned that if the carbonyl group is on the same number of carbon atoms at the extreme end. For example, if I'm told I'm dealing with a heptane, and then I'm dealing with a 7-oxo heptane, then the carbonyl group, which will be on the seventh carbon atom, it will be an aldehyde, because there is no other carbon at the other end. So I will expect a hydrogen. So, but any other position like a 4-oxo, then I know I've got a ketone. So from this name, there is a hydroxide group, there's an alcohol group on carbon number 3, and then there is a ketone group on carbon number 4. And then in this case, you've been told it is 6 carbon atoms. So based on that information, I've just tried to give you try to draw, you try to put something like 1, 2, 3, 4, 5, and 6. Can you see? There is a hydroxide group on carbon number 3, and then there is a ketone group on carbon number 4. This one you've drawn based on that structure. I'm just trying to say this is the University of Nairobi approach on how we tackle standard nomenclature questions. You understand? So now, based on this, now you come up with the rules that the ranking of the functional group. The most important functional group is the carboxylic acid number 1, then the aldehyde or a ketone on carbon number 2, then there is the alcohol on carbon number 3, then the amino group on carbon number 4, then something like what? I'm just trying to think. Then there is something like the what? The benzene, uh, 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 something like the double bond. Then there's the double bond and the triple bond. They usually run together. And then lastly, uh, for alkanes, something like a methyl group, something like the halogens, like the bromine, chlorine, iodine, fluorine, and also the ether groups. They usually run together. So it means if you've got an alkane and it has a methyl group, I mean alkyl groups like the methyl, ethyl, propyl and the rest. And also there is something like a halogen, like the chloro group and the bromo. And then there's also an ether group like methoxy, ethoxy. These ones, there is no ranking of higher other than the other ones, but you rank them alphabetically. Let's say like the one beginning with so you start numbering the chain from the one in which there's the lowest alphabet among other rules, yeah, which I think I laid down in the course. So based on these rules, you just know that the most important functional group is the ketone group, yeah. So the most important functional group in this first example is the ketone group. So for this example, uh, I'll give the number, then the IUPAC name will end with the name of the most important functional group, which in this case is the ketone. So this 1, 2, 3, 4, 5, 6. So it is a ketone with 6 carbon atoms. So the name it will be hexanone. Yeah. So the name it will be a what? The name will change to hexanone. And then I'm going to indicate the most important functional group is on carbon number 4. So it will be a hexane 4 on. So that will be the main functional group. Are you okay? Then now, the rest is just to see any other functional group. There is the hydroxy group. There is the hydroxy group. So the hydroxy group, so the fact that, let me see, 1, 2, 3, sorry. In this case, the most important functional group is on carbon number 3 because I'm going to start numbering from 1, 2, 3. Yeah, forget about this numbering in which I put something like they were put on that one. So the most important functional group is on carbon number 4, and then the hydroxyl group is on carbon number 3. So based on that information, the proper IUPAC name is what? 1, 2, 3, 4. So it is 4 hydroxy hexane 3 on. Okay? That is what will be expected. Can you see now? Yeah? So you're given a name which is not correct, but based on that name, you can be able to know the number of carbon atoms and the functional groups in that name. And then from there, you construct a structure, and then from structure, you come up with the proper IUPAC name. This is the standard way of the questions, the way they are tested on nomenclature. So I want to give another approach here because they are testing various concepts. Yeah. So the next concept which I want to give you, like I've given a name here, like uh, like for example, this is 3-amino 4-butyl pentanoic acid. Okay. Now straight away you know that your work has been made slightly easier. The fact that the main functional group which is given there is the most important functional group. So you just know that is going to be carbon number 1. Yeah, that you are dealing with a carbon chain. Like in this case, it's got 5 carbon atoms. So based on that one, let's just try to see. Once again, I construct like in that case, if I was to, based on this one, I'm going to come up with this one. Like I label carbon number 1, where there's the carboxylic acid number 2, number 3, number 4, and then number 5. Can you see that? So this tells you that there is an amino group, an amine group, an amino group on carbon number 3. And then there is a tertiary butyl group. By the way, for the alkyl groups containing 4 carbon atoms, it can be normal butyl, they can be secondary butyl, they can be, no, there can be secondary butyl, they can be isobutyl, and then the fourth one is tertiary butyl, yeah? So there are four types of the butyl group. So I think from this one, you know, the tertiary butyl looks like this one. Has got 1, 2, 3, 4. It's got 4 carbon atoms. So it is telling you you've got a tertiary butyl group on carbon number 4. Based on this information, you construct such a structure. And then once you come up with a structure, then you come up with, we now say, based on that one, is the information I've given correct? I see that one. So based on that one, what you do is that you identify now the longest carbon chain, which was the one which I had here did not have branches, so there was that information did not arise. But on this one, I've got to see, hey, if I count number 1, 2, 3, 4, 5, and then I move like 1, 2, 3, 4, 5, 6, then now the tertiary butyl now becomes part of the longest carbon chain. So this tells you now what you had as a pentanoic acid, the name is going to change. Can you see now? So that tells you that now the longest carbon chain will not be, it will be 1, 2, 3, 4. So this methyl becomes a substituent, number 5 and number 6. So that will not become number 5. It will become number 5 and then number 6. And then that tells you that there is a methyl group on carbon number 4, and there's another methyl group on carbon number 5, and another one on carbon number 5. Okay? The amino group on carbon number 3 remains at that position. So what is the proper IUPAC name? It is 3-amino. Then there are 3 methyl groups on carbon number 4 and 2 on carbon number 5. So there is 4, 5, 5 trimethyl, and then the longest carbon chain is pentanoic acid. No, hexanoic acid. Hexanoic acid. Can you see that? So this is now the name which is expected. You've been given this information. From this one, you reconstruct the structure and then you come up with the proper IUPAC name. We are together. I hope you are enjoying this session. This is the standard University of Nairobi approach on trying to show you how to understand. If you're going to understand this way, then there is any way questions on nomenclature can be set. You'll be able to unravel that one. Yeah, that in this case you're just being given a name, and then from there you can, hey, from this one I can be able to do this. And then from there I come up with the proper IUPAC name. Now the third one here uh, uh, contains the benzene, and you know the benzene has got that 6 carbon with 3 pi bonds. Yeah, that is benzene. Now it is telling you the benzene has got a bromo on carbon number 1. So that tells you, you just put carbon number 1 and then you just put 1, 2, 3, 4, 5, and 6, and you just label something like that. You just label a benzene like that, and then it's telling you on carbon number 2 you put a methoxy. It means there is an ether O, and then there is a CH3. All right, and then tells you on carbon number 4 there is a what? There is a hydroxy group, OH. And then that is the name which has been given. So that is the information. Based on this information, we construct this structure which is similar to what I've drawn here. Now, let's try to use the IUPAC rules to try to come up with the proper name for this. Now, it's telling you that which is the most important functional group. The most important functional group, the alcohols, they rank higher than an amino group or even something like a benzene. And we say where the benzene is a substituent on an alcohol, the name becomes phenol. So now, this becomes the most important functional group is now carbon number 1 there. Okay, because that shows you the reference to the most important functional group. And then you're going to number them in such a way as to give the substituents the lowest number. Like if I move like 2, 3, and 4, even though the the bromide group, one, two, even though the bromide group, okay, this other case, if I move like this one, the bromide group is still on carbon number 4. But if I move like this one, I'm going to give the lowest numbering to the methoxy group, yeah? Okay, so in this case, the proper name, it will be 4 bromo 3 methoxy phenol. And phenol is a short for phenyl alcohol. It's called phenol. Phenol is an IUPAC name for phenyl alcohol. Okay? So the proper name is 4-bromo 3-methoxy phenol. Are you saying that? Good. Now let's look at the last example on this one, on the nomenclature. This is just giving you concepts, yeah, on some of the things that, on some of the different some of the different approaches. In this case, you've just been told here there is an alkene and it has stoichiochemistry either E or Z. In this case, you've been told there's an alkene which has got a Z stoichiochemistry, and then you'll be told that alkene has got how many carbon atoms? Eight carbon atoms. And then so based on that one, what you do is that leave what I've done here. Okay, so let me say 1, 2, 3, 4, 5, 6, 7, 8. Yeah. So when I numbered it from here, maybe let me leave this one. Let me number it from this other side so that you see it differently. Are you seeing what I've done? I've taken that one, and then to make it an alkene, that tells you there is a double bond on carbon number 2, isn't it? So there is a double bond there, and then it is telling you on that carbon number 2, I put a what? I put a chloride group. Now that tells you that that the way I put the chloride group matters, because because if I would have put uh, my Cl here, and then my methyl group comes here, this becomes E, because chlorine is a high priority, and this group here is a high priority compared to the. Can you see here? There is a hydrogen on carbon number 3. There is a hydrogen here, so it tells you in this case you've got two high priority groups on opposite sides of the double bond, and therefore this becomes A. So in this case, for it to be Z, so the methyl group will still be there, and then the chloride group will be here. So this becomes Z because uh, this is most important, and also this is important group, they are on the same side. Yeah. So please look at your notes on how to differentiate between E and the Z alkenes. Yeah. Now that is one part which you have solved there. Then it is telling you on carbon number 6 there is an oxo. It means that there is a carbonyl group. And then I go here and then say on carbon number 7 I put a what? You know what, how an isopropyl group looks like, right? Now, with that information, let's just try to see whether let's now name the structure which you have here according to the IUPAC rules. Okay, so let us see. Do we have the longest carbon chain? And the thing is, as far as the IUPAC rules are concerned, you must maximize on the substituents. You make as many substituents as possible. That's why a compound like this one was not that calling it butyl is not an IUPAC name. What you do is that you maximize on as that butyl group is made up of other substituents. So if from its position you can get a longer chain, then I think you need to maximize on that one. But there comes a time when the butyl is at a position whereby you may not get a longer chain, and therefore you're just going to name it as a butyl the way it is. So in this case, let us say if I was to move like this, 1, 2, 3, 4, 5, 6, 7, 8. Let me see, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now if I move on this position, I'm going to get a longer chain than the 8 carbon atoms. So this is 6, 7, 6, 8, and then probably 9 here. Can you see there? All right. So the longest carbon chain is 9 carbon atoms, and then I'll need to come and see which is the most important functional group. Is there is a ketone, and that there is a ketone and it has a double bond. Okay. So that tells me that I've got with the 9 carbon atoms, the name would have been a no. It would have been a nonene, yeah, nonene, yeah. But the fact that I've got a double bond, the name changes to nonene, yeah. In E for the alkene, and then it tells you that that is if you only had a double bond. But now I've got a carbonyl group. So where there was the rather than putting an E there, I'm going to put an O, non. So it will be a 9 carbon atoms with a double bond with an in, and then the name will end with an on. Yeah, so that in this case, I will now see to give the most important functional group, I'll start numbering from here. So as to give this ketone, which is the most important functional group, the lowest number. So this is what I'm going to do. Okay. So that I'll start numbering from 1, 2, 3, 4, 5, 6, 7, 8, and then 9. Okay. And once you do that one, it tells you that the double bond is on carbon number 7, yeah? And then the ketone group is on carbon number 4, yeah? And then it tells you there is a chloride group on carbon number 8, and then there is a methyl group on carbon number 2, and then on carbon number 3. So what is the proper name? The stereochemistry does not change. The Z stereochemistry, that group and that group still remain there. So the proper name, it will be Z, it will still be Z, yeah? And then so you start numbering the substituents alphabetically. The first one is the chloride, which is on carbon number 8. It is 8 chloro, and then the other functional groups are what? Methyl groups. So the methyl group is on carbon number 2 and carbon number 3. So there will be 2, 3 dimethyl. Okay, okay. And then after that one, we are through with the other substituents. So so we now fix in this the place for the double bond and also for the ketone in the final name. So there will be non. Then the place for the double bond is on carbon number 7, 7 in, and then the ketone group is on carbon number 4, 4 on. Hey, this is a very long name. Can you see that? So it is Z8 chloro 2,3 dimethyl non 7 in 4 on. So this is the proper IUPAC name. So can you see that? Based on this name, even though it is not correct, yeah? So well, the name may not be correct, yeah? But based on that name contains information about the positions of the substituent and the functional groups. And also, if you have got the stereochemistry like the E or the Z, that is contained in the wrong name. And then based on that information, you come up with a structure. based on the name, even if it is wrong, you come up with a structure. And then from the structure, you now derive the proper IUPAC name. Once again, it may be tricky, but this is the standard way. Questions on nomenclature, if they will be there, how they are, excuse me, how they are set. Yeah, that. So this one of just the simple way in which you're just given a name, come up with a structure, or a structure come up with a name, that is not the standard way of how we do it. We started on this one about probably last year or the 2 years ago. Yeah. So this is the standard way for examination purposes in which questions on nomenclature are examined. Yeah. So I think let me stop there. I've just given you some tips. Once again, this is no leakage whatsoever. It's just telling that if there will be questions dealing with nomenclature, this is the standard way in which you're supposed to do that to really help you. I'm sorry I'm saying this when it's only like 3 days to the exam. Like so there is Friday, there is Saturday, and then there is Sunday, and for Monday. But I believe it's important for me to give you this approach because this is the standard way uh, of trying to avoid half-baked engineers. You're just going to be thinkers, yeah, in which you can be creative, yeah. What you're going. So after this one, after the at the end of this video, just going to post. Then I think the next person I want to just guide you on some of the things about calculations. That will be on the second video, and then probably on that one, or maybe I don't know. It may not be in the that one, but just want to mention something on the multiple choice because this is now the problem with the multiple choice is that if it is handled, if you guess and if you don't see correctly, the lecturers or the examiners, they try to ensure that there are some wrong answers, but they are very close to the correct one. And if you're not careful, you'd rather put your own answer. But if you take the one which you think is right and is wrong, then you end up losing the marks. That's the problem about multiple choice. But that's something which I'm going to mention later. So this is the first part that you need to know, that we how we test on questions on nomenclature. So there was the first one on this the wrong name 3 hydroxy 4 oxohexane. The second one was the second name which was wrong, but based on that we will be able to construct the structure was 3 amino 4 tert butyl pentanoic acid. That's the second one. The third one in this one was 1 bromo 2 methoxy 4 hydroxy benzene. And then the fourth one was Z in quote in bracket 2 chloro 7 isopropyl 6 oxo oct 2 in. Yeah. So based on that one, we've been able to reconstruct the structure and then come up with the proper name. So I think let me stop there. I believe you've really enjoyed this session. Yeah. All right. Good. Thank you.